They called at 1:30 a.m. while I was fixing the turbine crisis in Detroit, costing $87,000 per hour. Your employment terminates at 6 a.m. today. I said okay. I'll inform the plant manager you'll handle the repair since I won't be an employee. Suddenly they realized. The call came through at 1:30 a.m. while I was elbowed deep in the guts of a seized bearing that had shut down the main turbine at Midwest Steel Works. My phone buzzed against my hip through my coveralls. I ignored it. Then it buzzed again. I pulled off my work gloves and checked the screen. Shane Murphy, a new general manager, calling from his warm bed while I was lying on cold concrete trying to save his production line. My name is Mason Turner. I'm 56 years old and I've been turning wrenches on industrial turbines for 28 years. What happened next taught me the difference between being valued and being expendable. I almost didn't answer because when you're dealing with a bearing that's locked up tighter than a bank vault on a turbine worth $12 million, phone calls feel less important than the metal screaming under your flashlight. But 28 years of being the guy they call when everything's going to hell conditions you to pick up when management calls, even at 1:30 in the morning. Turner, speaking. Mason, it's Shane. I need to inform you of a company restructuring decision. Effective immediately. We're eliminating your position as senior turbine technician. Your employment terminates at 6 a.m. today. I looked at the bearing assembly in front of me. The main shaft was seized solid. Temperature readings showed the housing was still running 180 degree. The whole production floor was dark because this turbine generated power for half the plant. Rachel Martinez, the plant manager, was standing 10 feet away looking desperate because I was literally the only person in the building who knew how to rebuild a 1992 Westinghouse turbine this size. I understand, I said, keeping my voice steady. I'll inform Rachel that you'll be handling the turbine repair since I won't be an employee in 4 hours. Long silence. I could hear him breathing through the phone. What turbine repair? The main turbine that's been down since 11 p.m. last night, seized bearing on the primary shaft. It's costing about $87,000 per hour in lost steel production. I'm in the middle of a bearing replacement that requires another 6 hours minimum. Since you're eliminating my position, I assume you'll send someone else to finish it. More silence. When Shane finally spoke, his voice had changed. Mason, let's discuss this after you fix the turbine. I don't think that's appropriate. You just terminated my employment effective 6 a.m. It's now 1:37 a.m. That gives me 4 hours and 23 minutes left as a Midwest Steel employee. After that, I shouldn't be working on company equipment. Wait, Mason. I hung up and looked at Rachel. She'd heard enough of my side to understand what just happened. They fired you right now while you're fixing our turbine. That's what the man said. Effective 6 a.m. I'm no longer employed here. Rachel's face went white, but you're the only person who knows this system. What happens to our production? That's an excellent question for Shane Murphy. Before I explain what happened over the next week, let me tell you who I am and why that phone call was the most expensive mistake Shane ever made in his short career. I started at Midwest Steel Works in 1996, fresh out of 8 years in the Marines, where I'd learned that when machines break you fix them fast or people get hurt. The Corps taught me that reliable equipment keeps people alive. And that lesson stuck with me when I transitioned to civilian industrial work. Midwest Steel manufactures structural steel for construction projects across the Great Lakes region. When their turbines run properly, they produce about $2.1 million worth of finished steel products per day. When the turbines are down, the entire plant is offline and 400 people go home without pay. My job was maintaining the power generation turbines that kept everything running. These weren't modern computer-controlled units that some kid fresh out of engineering school could troubleshoot with a laptop. They were 1990s-era Westinghouse turbines built like tanks, but requiring hands-on knowledge to maintain. Over 28 years, I'd rebuilt every major component multiple times. I knew exactly how each unit behaved under different load conditions, which bearings wore fastest, how the cooling systems responded to temperature changes, and most importantly, I could diagnose problems by sound and vibration that would take other technicians hours of testing to identify. You don't learn that kind of knowledge from YouTube videos or technical manuals. You learn it by getting your hands dirty for 3 decades. By listening to how a bearing sounds when it's got 500 hours left versus 50 hours left. By feeling how the housing vibrates when clearances are getting loose. It's the kind of expertise that comes from honest work day after day, year after year. That knowledge made me valuable to the plant. That knowledge also made Shane Murphy think I was expensive and replaceable. Shane had been hired 8 months earlier with an MBA from some university and a mandate from corporate to modernize operations and reduce labor costs. He'd been pushing hard for outsourced maintenance contracts to replace what he called legacy workforce overhead. In his mind, my $85,000 annual salary could be eliminated by hiring cheaper contractors when needed. What Shane didn't understand, what they don't teach you in business school, is that specialized knowledge isn't the same as general labor. You can't just call up a contractor from the yellow pages and say, "Fix our 30-year-old turbine," when that contractor has never seen the specific modifications, repairs and workarounds that accumulate over decades of operation. But Shane was convinced he could modernize his way to better profit margins, and I was apparently part of the old way of doing things. The crisis that led to that 1:30 a.m. phone call had started 14 hours earlier, when the main turbine began showing abnormal vibration readings during the evening shift. I wasn't scheduled to work that night, but Rachel called me at home around 10:30 p.m. because the readings were getting worse fast. "Mason, I hate to bother you at home, but we've got some troubling numbers on Unit 1. Vibrations climbing and the temperatures running hot." I've been watching Monday Night Football with a beer, but when Rachel calls about turbine problems, you listen. She's been managing that plant for 12 years and doesn't panic easily. If she's worried, there's good reason. "What kind of numbers are you seeing?" "Vibrations at 8.5 milliseconds and climbing. Temperature on the main bearing housing hit 165 degrees about an hour ago." That got my attention real quick. Normal operating vibration on those old Westinghouse units should run around 3 to 4 meters. Anything over 6 meters means trouble. At 8.5 milliseconds, we were looking at potential catastrophic failure if something wasn't done soon. And bearing temperatures over 160 degrees meant the lubrication was breaking down. "Shut her down," I told Rachel. "Right now, don't wait for the numbers to get worse." Already did. "Triggered the emergency shutdown about 10 minutes ago. Can you come in and take a look?" I was pulling on my work boots before she finished asking. "Give me 20 minutes. The drive to the plant gave me time to think about what could cause those symptoms. High vibration combined with elevated bearing temperature usually meant one of three things: bearing wear, shaft misalignment, or contaminated lubrication. Given the age of the equipment and the maintenance history, my gut said bearing wear. Those main shaft bearings had been in service for about 4 years, which was approaching their expected lifespan under continuous operation. When I got to the plant, Rachel met me at the entrance with the maintenance logs and recent inspection reports. The night shift supervisor, Tommy Rodriguez, was waiting by the turbine with his flashlight and a worried expression. "What do you think, Mason?" Tommy asked. "Never seen vibration numbers climb that fast." I spent the next 2 hours with my hands on that turbine, feeling for abnormal vibrations, listening to the sounds it made as it cooled down, checking clearances and alignments. The diagnosis wasn't complicated if you knew what to look for. The main bearing had developed excessive clearance due to normal wear, allowing the shaft to wobble under load. The wobbling created heat, which expanded the metal and made the problem worse until the automatic shutdown system kicked in. "It's the main bearing," I told Rachel around midnight. "The clearance has opened up beyond tolerance. We need to pull the shaft and replace the bearing assembly." Rachel ran the numbers in her head. "How long for the repair?" "If everything goes smooth, about 8 hours. That's assuming I can get the right bearing from our supplier and nothing else goes wrong during disassembly." "What's it going to cost us in lost production?" "About $87,000 per hour while we're down. Maybe $700,000 total if I can get it done in 8 hours. Rachel made the call to approve overtime and emergency parts procurement. I called our bearing supplier and arranged for a rush delivery of the replacement bearing. Cost was $3,200 for the part, plus another $800 for same-day delivery. Expensive, but a lot less expensive than extended downtime. I started the disassembly work around 12:30 a.m. First step was draining the lubrication system and removing the housing covers to access the bearing assembly. Then came the delicate work of lifting the turbine shaft using the overhead crane and supporting it properly while I pulled the old bearing. That's when Shane called and fired me. After the first hung up on Shane, Rachel looked at me like I'd lost my mind. "Mason, you can't just stop working. This turbine needs to be fixed." "Rachel, I understand your position, but I was just terminated. I can't ethically continue working on company equipment when I'm no longer a company employee. This is insane. You're the only person who knows how to rebuild this turbine. What am I supposed to tell corporate when they ask why we're still offline?" "You tell them." Shane Murphy eliminated the position of senior turbine technician at 1:30 a.m., while the plant was in the middle of an emergency repair. Rachel pulled out her phone and started making calls, first to Shane, who didn't answer, then to Jordan Phillips, the COO in Chicago. I could hear Jordan's voice getting louder through the phone as Rachel explained the situation. After 20 minutes of heated conversation, Rachel hung up and looked at me. Jordan wants to reinstate you immediately. Full back pay, promotion, whatever it takes to get this turbine fixed. That's nice of Jordan, but Shane was pretty clear about my employment status. I was terminated. Effective 6 a.m. It's now 2:15 a.m., which gives me less than 4 hours left as an employee. Mason, be reasonable. This is obviously a mistake. Maybe it is, maybe it isn't, but Shane made his decision, and I'm going to respect it. At 6 a.m. I stopped being a Midwest Steel employee, and I stopped working on Midwest Steel equipment. Rachel started pacing around the turbine like a caged animal. Every minute we stood there talking was another $1,450 in lost production. Every hour the plant stayed down cost more than most people make in a month. What if we hired you as an independent contractor? She asked. Emergency maintenance contractor working directly for Midwest Steel but not as an employee. I thought about that for a minute. It was an interesting proposition. What's your budget for emergency contractors? Whatever it costs to get this plant running. Every hour we're down, we're losing $87,000. If you can fix this turbine in 8 hours, we'll still come out way ahead. I quoted her my standard emergency contractor rate, $1,200 per hour, 8-hour minimum payment in advance. That was about 15 times what I made per hour as an employee. But it was still cheaper than keeping the plant offline. Rachel didn't hesitate. Done. I'll have accounting cut you a check right now for $9,600. One more thing, I said. As an independent contractor, I work by my own schedule and methods. No interference from management, no second-guessing my procedures. I fix the turbine my way or you find someone else. Agreed. Just get us back online. At 5:45 a.m. Rachel handed me a company check for $9,600. At 6 a.m. sharp, my employment with Midwest Steel officially ended. At 6:05 a.m., I resumed work on the turbine as Turner Maintenance Services independent contractor, earning more money in one day than I'd previously made in 6 weeks. The bearing replacement went smoothly once I had the right tools and the freedom to work without some MBA looking over my shoulder, questioning every move I made. That's the thing about skilled work. It looks easy when you know what you're doing. But there's 1,000 ways to screw it up if you don't have the experience. I had the turbine shaft supported on jack stands while I pressed out old bearing, using a hydraulic puller. The bearing came out clean, which was good news. Sometimes when bearings seize, they take part of the housing with them, and then you're looking at machining work or even a complete shaft replacement. This one had just worn beyond tolerance normal wear for a bearing that had been running 24/7 for 4 years. The new bearing pressed in perfectly. I checked the clearances with feeler gauges -0.3 and radial clearance right where it should be for a bearing that size. Then came the careful work of reassembling everything with proper torque specifications. The main bearing cap bolts get torqued to 450 feet lb in a specific sequence to ensure even pressure distribution. Miss that sequence or under-torque those bolts and you'll have the same problem again in 6 months. By 1 a.m. I had the mechanical work finished and was ready to start the lubrication system. That's another step where experience matters. You can't just dump oil into the system and fire it up. The lubrication has to be circulated and heated gradually to prevent thermal shock to the seals and gaskets. The oil temperature needs to reach 120 degrees before you can safely start the turbine, and that takes about 45 minutes with the circulation pumps running. While the lubrication system was warming up, Rachel came over to check on progress. How much longer, Mason? Another hour for lubrication warm-up, then about 30 minutes for startup sequence and testing. We should have power restored by noon, thank God. Corporate's been calling every 15 minutes asking for updates. They're not happy about the production loss. Maybe they should have thought about that before they eliminated their senior turbine technician in the middle of an emergency repair. Rachel shook her head. Shane's been trying to call you all morning. Jordan Phillips wants to talk to you too. I'm sure they do, but right now, I'm focused on getting your turbine running. That's what you're paying me $1,200 an hour to do. The startup sequence began at 11:15 a.m. First I engaged the turning gear to rotate the shaft slowly and check for any binding or unusual resistance. Everything felt smooth. Then I started the lubrication pumps and gradually brought the oil pressure up to operating levels. The pressure held steady at 45 psi, right where it should be. Next came the actual turbine startup. I opened the steam valve incrementally, bringing the turbine up to speed gradually while monitoring vibration and temperature readings. The vibration stayed below 2 meters throughout the acceleration, better than it had been running before the bearing failure. Temperature readings were normal across all monitoring points. By 11:45 a.m., the turbine was running at full speed and carrying electrical load. By noon, the production floor was back online, and steel was moving through the rolling mills again. Total downtime, 13 hours. Total production loss, about $1.13 million. My contractor fee, $9,600. Rachel was watching the production monitors with visible relief as finished steel products began moving through the facility again. Mason, I can't thank you enough. You saved us from what could have been a complete disaster. That's what you paid me for. I'll write up a technical report on the bearing failure and replacement procedures. You should share that with corporate so they understand what happened and what it cost them. Will you consider coming back as our head of maintenance? I'm sure we can work something out with corporate. I appreciate the offer, Rachel, but I've got to say this contractor arrangement is looking pretty attractive. I made more money today than I usually make in 6 weeks. Around 100 p.m. my phone started ringing. First Shane Murphy, then Jordan Phillips, then someone from corporate HR. I let them all go to voicemail while I finished documenting the repair work and cleaning up my tools. Shane's voicemail was interesting. Mason, there's been a misunderstanding about your employment status. Please call me back immediately so we can resolve this. Jordan's message was more direct. Mason, this is Jordan Phillips. We need to discuss your situation. Shane made an error in judgment. We want to make this right. But the most interesting call came at 2 p.m. from a plant manager I'd never met. Mr. Turner, this is Bill Crawford at Great Lakes Manufacturing in Toledo. We heard through the grapevine that you're doing independent turbine maintenance work. We've got a 1988 General Electric turbine that's been giving us problems, and our regular maintenance contractor can't figure it out. Would you be available for a consultation? Word travels fast in industrial circles. By the end of that week, I'd gotten calls from 6 different manufacturing plants across Ohio and Michigan. Plant managers talk to each other at industry conferences and trade association meetings. When someone finds a turbine specialist who can solve problems that stump everyone else, that information gets shared. Each had the same story: critical equipment failure, local maintenance. Staff couldn't diagnose the problem. Regular contractors were either unavailable or didn't have experience with older equipment. Could I help as an emergency consultant? I helped every one of them. My rate stayed at $1,200 per hour for emergency work, and I was averaging about 80 hours of billable time per month. That works out to roughly $96,000 monthly, or over $1.1 million annually. More than 13 times what I'd been making as Midwest Steel's employee. But it wasn't just about the money. These plant managers respected my expertise because they'd seen what happened when specialized knowledge wasn't available. They understood they were paying premium rates for premium results. Nobody questioned my methods or complained about my fees after I'd restored their production equipment and saved them from extended downtime. By September, I'd incorporated as Turner Industrial Services and hired 2 other experienced turbine technicians who'd been laid off during various cost reduction initiatives at plants around the region. Carl Washington had 24 years of experience with steam turbines before his plant eliminated his position to streamline operations. Mike Sullivan knew gas turbines inside and out after 31 years at a power generation facility that decided to outsource their maintenance to save money. These weren't guys fresh out of technical school. They were craftsmen who'd spent decades learning their trade, only to be told their skills were obsolete by managers who couldn't tell a bearing from a bolt. We became the go-to team for complex repairs on older industrial equipment that companies had written off as unmaintainable. The irony wasn't lost on any of us. Companies were paying us 3 times what we'd made as employees to fix the same equipment we'd been maintaining before they eliminated our positions. The real satisfaction came 3 months later when Rachel called me with news about Shane Murphy's career at Midwest Steel. Mason, I thought you'd want to know. The board terminated Shane yesterday, effective immediately. I was in my new shop at the time, a 4,000 QFT facility I'd leased on the outskirts of Detroit to house Turner Industrial Services. We'd outgrown my garage pretty quickly once word got around about our emergency repair capabilities. What finally did it? I asked, though I had a pretty good idea. The numbers. They calculated that Shane's cost-cutting decisions ended up costing the company over $8.2 million in direct losses over 8 months. The turbine downtime was just the beginning. 2 other clients reduced their contracts after hearing about our maintenance staffing problems. Plus, we've been paying premium contractor rates for repairs that used to be handled in-house. Shane's expensive lesson had ripple effects beyond that one emergency repair. When you eliminate experienced maintenance staff, you don't just lose their labor, you lose their institutional knowledge, their relationships with suppliers, their ability to prevent small problems from becoming big problems. The guys who got laid off in Shane's modernization effort were the same guys who knew which valve sounds different when it's starting to fail, which bearing gets hot when the ambient temperature rises, which control system quirks require manual adjustment during seasonal changes. Without that knowledge base, minor issues that used to get caught during routine maintenance were now becoming emergency repairs. Emergency repairs cost 10 times more than preventive maintenance. And that's if you can find contractors who actually know what they're doing. Who's replacing him? I asked Rachel. Jordan Phillips is taking over as interim GM while they search for a permanent replacement. Jordan specifically asked me to reach out to you about a consulting arrangement. 2 weeks later, I was sitting in the conference room at Midwest Steel across from Jordan Phillips and the plant's new maintenance director, discussing a formal maintenance contract for Turner Industrial Services. Mason, I want to be straight with you. Jordan said Shane's approach was wrong, and the company paid a heavy price for his mistakes. We understand now that experienced maintenance personnel aren't just labor costs, they're operational insurance. We want Turner Industrial Services to handle emergency repairs and serve as backup for our internal maintenance team. The contract they offered was generous, $18,000 monthly retainer for priority response and consultation, plus $1,200 per hour for actual repair work. The retainer alone was more than double what I'd been making annually as their employee. But the most satisfying part wasn't the money, it was the respect. Jordan understood that specialized expertise has value that goes beyond simple labor calculations. When you eliminate that expertise, you're not cutting costs. You're transferring those costs to emergency situations where they become much more expensive. By December, Turner Services had maintenance contracts with 7 different manufacturing facilities across the Midwest. We specialized in older industrial equipment that most contractors wouldn't touch. The 1980s and 1990s era turbines, compressors, and generators that formed the backbone of American manufacturing, but required hands-on knowledge to maintain properly. The work was steady and profitable, but the real reward was working with guys who understood the value of craftsmanship. Plant managers who'd seen production lines shut down for days because some MBA thought experienced maintenance workers were overhead knew better. They paid our rates without complaint because they'd learned the hard way that expertise isn't something you can download from the internet or outsource to the lowest bidder. We also started taking on apprentices, young guys who wanted to learn the trade properly instead of just getting a certificate and pretending they knew what they were doing. Jake Morrison, 22 years old, had been working dead-end jobs since high school until his uncle recommended him to us. Now he's learning to read vibration patterns, understand bearing temperatures, and most importantly, how to listen to what a machine is telling you about its condition. There's no substitute for time and experience. I told Jake during one of our training sessions, you can memorize all the technical manuals you want, but until you felt how a bearing sounds when it's got 500 hours left versus 50 hours left, you're just guessing. Teaching Jake and the other apprentices reminded me why this work matters. We're not just fixing machines, we're keeping American manufacturing running. Every turbine we repair, every production line we restore represents jobs for hundreds of workers who depend on that equipment to earn their living. The skills we use aren't obsolete. No matter what some business school graduate thinks, they're the foundation that everything else is built on. You can automate a lot of industrial processes, but when something breaks, you still need someone who understands how the machinery actually works to get it running again. Shane Murphy learned that lesson the expensive way. He thought he could eliminate legacy workforce overhead and replace decades of experience with cheaper alternatives. What he discovered was that institutional knowledge isn't overhead, it's infrastructure. When you eliminate it, you don't save money, you create vulnerabilities that show up at the worst possible moments. Last month, I got a call from a plant manager in Wisconsin whose main turbine had failed during peak production season. Their regular maintenance contractor couldn't diagnose the problem, and they were losing $120,000 per day in production capacity. Mr. Turner, we heard you can fix problems that stump everyone else. How quickly can you get here? I was on site 6 hours later. The problem was a control system modification that had been installed in 1994 and wasn't documented in any current technical manuals. It took me 20 minutes to identify the issue and another 4 hours to fabricate a replacement component in their machine shop. Total repair time, less than 1 day. Total cost, $12,000, including travel time and materials. Without that repair, they would have waited 3 weeks for a replacement part from the original equipment manufacturer, costing them over $2.5 million in lost production. They paid my invoice without question and immediately signed a maintenance contract for emergency response services. That's what Shane Murphy never understood. The most dangerous thing to eliminate isn't the person who complains the loudest or costs the most on paper. It's the specialist who quietly keeps everything running until the day you decide their expertise isn't worth paying for, because specialized knowledge doesn't disappear when you eliminate the specialist. It walks out the door with them and becomes available to everyone except you. And when the next crisis hits, and there's always a next crisis, you discover that institutional expertise can't be quickly replaced, easily substituted, or downloaded from a manual. Sometimes the most effective response to being undervalued isn't arguing or pleading for recognition. It's simply allowing people to experience the full consequences of their decisions, while you build something better with the skills they thought weren't worth keeping. Shane wanted to modernize by eliminating experienced workers. I helped him achieve that goal. What he learned was that modernization without expertise is just expensive chaos, and that the real value of knowledge isn't measured by what someone pays you for it. It's measured by what they lose when they don't have access to it. When you fire the guy who knows how everything works, you don't eliminate a problem. You become the problem that needs solving. The difference between a cost and an investment is simple. Costs disappear when you cut them, but investments disappear when you need them.